Hey guys, today we'll be looking at the second half of exercise 4.4, which is referred to as matrix multiplication. So when we were looking at scalar multiplication, it was where we were multiplying matrices by a single number or value. In this case, it's where we actually multiply matrices together. So matrix multiplication refers to when we multiply matrices together. Now this is probably our trickiest concept so far in matrices. It's not as clear as adding and subtracting. The matrices, when we multiply them together, don't necessarily have to be the same order, and it's not as simple as multiplying corresponding elements together. So we don't just multiply the two in the top left together or whatever. It's a bit more complex than that. What I'm going to do is I'm going to write out the rules of when we can multiply matrices and what the product matrix is going to look like. And then I'll put it out in a bit more of a formulaic way that might make a bit more sense. All right, so Alright, so this is our major rule when multiplying two matrices together. The number of columns in the first matrix must be equivalent to the number of rows in the second matrix. Now, normally with numbers, when we multiply them together, their order is irrelevant. 6 times 2 is 12, 2 times 6 is 12. That doesn't work that way with matrices. The order in which we multiply them is very, very important. In fact, it changes our answer in every circumstance. So let's just say, we're not going to actually multiply those two matrices together, but looking at an example, say we have two matrices, A and B. What we're going to do here is we're going to determine whether they can be multiplied together and that they can get a product matrix. A product matrix being the answer once two matrices have been multiplied together. Alright, so the shortest way to do it is this. Matrix A, its order is 2 by 3. Matrix B, its order is 3 by 2. So if we want to actually solve what A times B is, so AB means A multiplied by B, we can look at their orders, look at them next to each other, and if that middle number is the same, it means that they can be multiplied together. Alright, so I'm just going to write it in brackets. This means that order of matrix A, 2 by 3, is getting multiplied by the matrix B, which has an order of 3 by 2. Those two middle numbers there are the same. So what that means is that they can be multiplied together. The answer will get us an answer. It does exist. If we were to reverse the order, alright, matrix B, which has an order of 3 by 2, getting multiplied by A, which has an order of 2 by 3, Look at the two middle numbers. Again, they are the same, therefore these two matrices can be multiplied together. So what we say is that the product matrix of AB and BA exists because they can be multiplied together. So that's kind of the first concept within this whole topic of matrix multiplication, being able to determine whether the matrices can actually be multiplied together or not. In both these cases, yes, they can, because the numbers are the same in the middle. The number of columns is equal to the number of rows. Columns is equal to rows. If, for example, this was 2 by 1 instead, it wouldn't work. So it's really, really important to notice that. Now, the second main thing to note is what the order of our answer is going to be. So the order of the new matrix. Because if we were to multiply these together, they've got different orders. So we need to figure out a way to actually work out what the order of the new matrix is going to be. All right, so the order of the product matrix is equal to the number of rows in the first matrix by the number of columns in the second matrix. Having another look at this example here, the number of rows in the first matrix is 2, number of columns in the second matrix is 2. So the order of AB, if we were to multiply these together, would be a 2 by 2 matrix. As a general sort of algebraic way to represent this, say we had a matrix of order m by n, so this could represent any, multiplied by another matrix with an order of n by p. Right, so pretend they're numbers. The two in the centre are the same. And then the order of the product matrix, once you've established that the essential are the same, will be the two outside numbers. So that's kind of the second concept that establishing matrix multiplication. The next part is to actually multiply two matrices together. I just want to go over one more example of proving whether two matrices can be multiplied together and what their final order will be. All right, so we got two matrices, C and F. First one, C multiplied by F. Not actually going to solve this, but just going to determine whether they can be multiplied and what their product is going to look like. All right, so matrix C has an order of 2 by 2. Matrix F has an order of 2 by 1. Two numbers in the middle are the same. Those columns are equal to the number of rows. Our product matrix, or the answer, will be 2 by 1. If I wanted to reverse those, and I wanted to do F multiplied by C, as we know, matrix F, 2 by 1, matrix C, 2 by 2. Sorry if that's a bit small. Two middle numbers are different, can't be multiplied together, so we stop there. Depending on the question, you might need to write a little mini conclusion like the product does not exist or something like that, but we would stop there. We conclude that it can't go any further. Answer is not 2 by 2 because we first have established that those two middle numbers are different. Alright, I might split this into two videos so they're not too large. The second video, which will be in the compass link, will be going through a full detailed example on how to multiply two matrices together. Make sure you've got all those notes down before commencing the second video.